I hope that you all learned something great from the session today, which will interestingly be about the past, present, and the future of AI or artificial intelligence. And it will be presented by our guest speaker, Mr. Vitou Phy, who is a CS alumni. Yeah, so with that being said, I would like to welcome Mr. Vitou, who will share with you on that. And if you have any question during the session, please feel free to write them in the chat or wait until the Q&A part, and I will call you out to ask the question through the microphone directly. Okay, so let us begin. Vitou.
Okay. By the way, will it be in Khmer or English or mixed?
Uh, I think because we have some foreign speaker, well, so
Okay.
and I mean audience, foreign audience.
Okay. So there's this new features in Google Slide. I'm gonna try it. Share the tab. Uh, what? Okay. Testing.
Yes, Bong, we can see your slide. Yes.
Okay. Cool. Cool. So hello everyone. Today I'm gonna talk about the past, present, futures of AI. Um, it's going to be a bunch of things mixed together. But I hope you'll find something useful out of this. Okay, so this would be the overview of today. We have some set introductions like what is AI, the past, present, futures, and so on. Okay, so let's just start with oh, by the way, my presentation will be quite short than the schedule, maybe like 15 minutes to 20 minutes. So I think we can leave room at the end for Q&A so that we can have discussions and so on. So yeah, my name is Vitou Phy. A lot of people confuse that, but it's okay. And in 2017, I finished CS at Xiamen, not Paragon, but Xiamen at that time. And in 2018, I started my journey to the east, the northeast, which is Japan, under Max Scholarship at that time. And in 2021, I finished my master in computer science at the University of Tokyo. My research topic at that time was about natural language processing, particularly about chatbot. And right now, I'm working as application engineer at Rakuten. Okay, let's get on to business. So, like, what is AI? Is this some sort of how do you call it? Just fancy word, but technically, when we hear it, we tend to think of like robotics, like Wall-E or something, some other robotics, like self-play Mario or self-play Go that beats the champion, or the self-driving car. We think AI as like wow, that intelligent agent sort of. So is it really that the case? I think if you look back earlier, these examples would be considered as AI as well, just maybe a low intelligence or a bad AI per se, but still AI, which means it in a sense resembles some sort of intelligence. So for example, in Pac-Man, the AI would be the you can see my mouse. Oh, cool. Would be this blue thing here that tries to attack the player. So they have to travel well and find the best way to hit the player. That's like one form of AI. Another one is tic-tac-toe. Like this is like throw. But yeah, like you just try to beat another, and it can be as simple as spelling detections and so on. So to me, in a sense, like AI is like just an agent that it can do a task, can complete a task that some sort of mimic a little of human intelligence, just little, not this ginormous intelligent agent, but just a little bit is what I would also consider as AI. Okay, so if we look into the past, at that time things were pretty much rule-based, which means you write the rule manually by itself, telling the agent what to do in a certain scenario. So for example, in the tic-tac-toe, for example, the player is the cross here and the AI is the O. So in this case, we just simply write in the code that if the AI see this type of board. If the AI see this, then don't think. Just put the O over here. And if then the player would put here, and then if the AI see this one, then it's over. Like you will lose either way. So just put randomly. It should be fine. The point here is that before things are defined by human, we determine which rule to apply to it. Just another example would be the spelling detections. So for example, what is AI? Just for example. And then we would try to split it into words, like tokenize it. And then for each word, we try to compare. So we have a list of dictionary. Let's say we take from Oxford Dictionary and type all the words in. So we have all the words, right? Anyway, so, and then we can compare, okay, so this word right here, does it match with any word at all in our dictionary? And if it does, then it is the valid word. And if it's not, then it is the wrong word. And we just highlight them. So yeah, these are the rule base that we determine clearly what's going on. But then in 1990s, machine learning started to pop up. Yeah, it started since that time, but it's more popular right now, but it started since that time. And so at that time, people tried to say, okay, now use rule is boring, sort of, or it cannot cover all the rule. So let's just try to use data and let the machine figure out the rules. So in our case here, let's look at the classical data sets, the iris data sets. So in this case, we have 3 types of iris flower: versicolor, setosa, and janica. And so at the 90s era, or the 2000s-ish, people would tend to take the image and do some sort of method, functions, or algorithm in order to extract some features. And that can be like colors, or they can try to use some method to measure the petal width, the petal length, and so on. And then we can put this into machine learning to determine what it is. Of course, if we think about it, in this case, we can just say, if it is setosa, maybe the width and the length is small, so we can just write a simple if else saying that, okay, if the petal is small, it would just be setosa. But that's the predefined rule, and there's also a way to try to have the machine figure that out. So this is just one of the techniques in machine learning, which k nearest neighbor, or KNN. So for example, we have bunch of data, bunch of the 3 types of flower. We have lots of them. So, and then we just put them into this plot, and this is like the petal width, this is like the petal length, and then we just put them out here. And so now suppose that we want to predict or determine or classify the next images, or what it is. So we can have a dot right here, and then we can try to find the nearest neighbor to that point. So in this case, it's like this 3 points. So now we see that, okay, all of the points that near to this point, the new point here, are the red one. So okay, this thing here may probably be red as well, which is setosa. So that's how, in a nutshell, that's how machine learning works. So this is just one of the example, is that you have a bunch of data, and then you just put in your thing that you want to predict, and hopefully it works out. So in this case, you do not need to determine the rule anymore, but the rule will be determined for you based on the data. Okay, and then we're moving on to the present, the more of like the deep learning, the black box that we don't know what's going on inside. What people do is that, okay, so people will be like, okay, let's try to take out the feature extractions, maybe, and just let the model do everything by itself. Let the model decide which one is important, which one is not, which one to features to extract, and so on. Okay, so in this case, things would be a little bit different. We have the image, and then we would put the image directly to the deep learning model, or the black box, and the deep learning model would try to predict a value of which flower it is. The scoring functions, or the loss functions, will see, okay, this is the predictions, and okay, this is the actual golden data. Like this is the real label for this image, for example. So now the score function here will determine whether this prediction is correct or not, is correct or not. So, and then the score will be feedback into the system, and the system will try to adjust its parameter. To be a little bit more technical, just a little bit more technical, we have this image here, and then we would try to put all these 2D images into one long array, like into this input layer. And then here is like the neural network is at each neuron here, and then it would try to predict the output. Let's say, for example, this is the setosa, this is the flower number 2 or flower number 3. And what each node does is that it tries to, so the input here, it would be the each pixel, and then the neural here would try to take 2 neurons and then combine them together, or maybe take all of them and combine them together, or maybe take 2 and minus this 1. So each neuron would first randomly try to do something, and this thing here would function the same as this one. It will take this one as the input and so on. And then, for example, it predict this one is the answer, that it says, okay, this is a versicolor. And if it's wrong, then it looks back. Okay, now which neuron says this is the right answer? So they would try to change, adjust the weight, adjust the parameter, and so on. So the feedback loop would, how do I say? So for example, if this one says take this one and plus this one, and then the answer is wrong, and then this one would change into, okay, now let's try this one and plus this one instead, and see if it gets better. This is just a vague explanations, but I hope you get the ideas. In short, each layer will try to plus and minus or something, and then at the end it will try to modify itself so that it can give a better answer. Okay, so what does each layer do? Like we have this multiple layers of network. Like what's going on inside there? And pretty much we don't know. Like we have no idea what's going on. All we see is just a bunch of numbers, and we don't even understand why they plus this together or why they minus this together. We don't know. But people like to hypothesize the following assumption, that maybe, just maybe, and it has some sort of proof behind that, but people tend to say, okay, maybe this first layer is what we call like edge detections. So for example, in terms of face, this first layer here would try to find the edge of the face, and then the second layer would try to find the portion, the segment, the regions of the face, and then the third layer would try to find the abstract representations of the face. Again, pretty much we don't know, but this is just one of the paper. But that's what people in the community like to think. The lower layer capture all this basic functionality, and the higher layers would capture more of the abstract representation. Okay, so in short, let's try to understand what's going on in the current here. Is that we have a model, we have the input, and we have the output. That's it. Like we don't do any clever feature. Well, we can do feature extractions, but you can also don't do anything and just put in the input and take in the output. So for example, in terms of translations, you can just say, okay, the input is hello and the output is Usday. And you don't tell any rules, you don't tell hello is a noun or a verb, you don't tell anything. You just give it like that, and hopefully pray to God that the machine translations can capture that and output that. Or it can be some sort of object detections, where you can just give an image and try to say, okay, and this is like we pre-labeled it and then train the model to do the output. So okay, like this is the dog, this is the bike, this is the car, and so on. Again, note that the label that we want to do is predefined by human already. So then the model would just learn to mimic that. Or it can be like post estimations, where you have an image and the model would just try to find the joint, like where is the joint, where would the skeleton looks like, what is the motion at that time. But the idea here is that we put the image and then the output is the skeleton. And again, we don't tell them anything. We just put it and hopefully it can detect that. And if not, we just try to change the model. Note that the model here would not based only on the thing I showed earlier here, not based on only on this one, but it can be CNN, LSTM, a whole bunch of complicated models, hopefully to make it work. But still, do we know what's going on inside? Not really. Eh, a little bit, but not really. Okay, anyway, so would be some other use cases. For example, it can be for the customer service, like you could have your shop, and then instead of hiring a lot of people, you can have a chatbot to act as the front line of customer service so that it can reply and give info very quickly. Or it can be some sort of image analysis, like smart farm, for example, that you flown a drone and then let it determine like what's going on in this land, like maybe what kind of crop would be ideal for this region right here. Or it can be, I don't know, maybe use this post estimations to detect robbery. Like for example, you put a camera in your shop, and then if someone have a pose like they're holding a gun, and then it can alert and so on. So yeah, I think that the use case can be quite practical. But what would be the limitations? Like I think a lot of people would say, wow, it's AI. We just need data, we just put it in, and it just works. But that's not the case. Okay, so for example, there is some huge limitations right now in AI. So for example, the Mario here that it can place by itself, which is pretty amazing. But it can only know Mario. If you try to take this knowledge and apply to Pac-Man, it's flop. If you take this knowledge to apply to Tetris, it will not work. So it only knows the domain that you train it on. This is another example that people want to classify the fish. Like what type of fish is this? And apparently we have provided a bunch of images, and then we think that, okay, I will answer that later. Okay, we have a bunch of images, and then we try to hopefully it can detect the fish, right? But actually, when we look at how the AI look into the images, we realize that the AI didn't look at the fish. The AI looked at the face angle, because for this type of fish, people always hold it like this. And so AI, instead of looking at the fish, it looked at the finger. So this means that if they see this finger, oh, it must be this kind of fish. And this is the some sort of limitations in that is that because we feed the data to the AI try to find which pattern can guarantee the most results or the most score within that data set. And so that's what also leads us to why self-driving car did not work. And please, I think Tesla has arrived in Cambodia, and please do not hack or jailbreak Tesla to do self-driving. Like, do not do that. Do not do that. Why? Because like even in US and so on, it still didn't work well. So for example, it can detect the truck, okay? But what if a truck has a picture of a kid? Let's say they sell ice cream, and so they have a kids on that. Would the car stop immediately because there's a kid right there? It can either run over the fake kids or not. So if it stops, then there will be accident on the highway and so on, which is bad. So um, that's one of the reasons that AI is too confused in this case. And it also didn't work, for example, with different lighting, if it's rain, if it's sunny, and so on. And if you change the city, some city has the hand railing and some do not. And if they do not, they might confuse the AI in some other way. And they might even know tok tok, which is bad. Anyway, so in short, what I'm trying to say here is that it knows the data that it's trained on, and if you change the environment, it can be problematic. So how should we use this? Okay, I think in short would be try to narrow the task, because to me AI it's good at remembering things. So if you can narrow the task, it would be good, and try to use it. Okay, let's just look at the example here. If you want to do like a dog door opener automatically, you can just train the model not to open the door, but train the model to detect if it's a dog, and then you can write a manual code to determine if it's a dog and then open the door. Or same with post estimations here. Instead of determines this image whether to determine if it is robbery or not. We can determine the pose and then try to classify whether this pose is robbery actions or not. And again, so okay, first of all, narrow the task. Second of all, try to use cautiously. Like always look at the test data sets that your model didn't work well, so you can know what's going on. And of course, like do not expect the model to work well on the new setting. Just assume that it will not work well, and always test it out. Okay, so what would be the future of AI? I think I'm going to focus a little bit on the research field. Is that now the AI, in a sense, to me, is like hit the limits. So I think we need to focus on the different approach, like generalizations. If you trained on the dataset A, you should also test on the dataset B as well, just to know how well it generalized to the other datasets. And the other thing is common sense that people try to tackle this in 1980s, and it's still not so good right now, is that if there's a fire, is it good or bad? Like let the model absorb those kind of knowledge. So for example, you have Roomba at home, or you have some sort of cleaning service robots at home. Is there a fire? Should they still be doing their task, or should they stop their task and try to alert or some other way? And remember about generalizations. So for example, if there's flood, like of course people would not think of flood because it might not happen often, but in Cambodia, the house can get flooded easily. So the bot might be surprised in that sense, and it might not work, and it can still try to clean the house even there's a flood. So common sense is also important in this case. I think these two things are important to tackle in order to break through this field further. Okay, this is just some thoughts, quick thoughts on what happened if we actually solve this. Like imagine, like I think self-driving car is there for a reason. It's not. I think it's not really to give us convenience, but to reduce traffic jam, traffic accident, especially traffic accident. I think it can save a lot of lives. In this case, if it works really well, and in our case, I think we would drive more maturely or drive more properly and avoid traffic jam. I think if you solve this, we can also have a better like machine delivery. Like I think we have seen some trucks and have some robotics inside the truck that deliver the package or deliver through the drone. Right now, the drone is sort of okay because the air is still nothing in there. But I think if it gets a little bit more dense, it could be also problematic. And of course, the personal assistants, like Samsung has unveiled like this new robots that they can pick up the plates and so on, put into the dishwasher. But again, I don't think, and of course, it will not be generalized enough to different type of housing. Maybe a specific kind, but not to all type of houses. And it can be more things, like imagine like personal teachers, which can teach your sons or your kids at home some questions. Like of course, teacher is busy sometimes, but if you have personal ones, it could be better. Personal doctor, personal companion, like when you're bored or sad or something. But anyway, so I think the applications of this is limitless, but the blocking point is the generalizations and the common sense. So yeah, I think that's pretty much it. I think some key takes away here is that first of all, just keep in mind that the AI deep learning, it's good at remembering things, not so good at generalized. I think it's like that's my rule of thumb, and try to apply to narrow task. And be careful in productions because there could be data drifting and so on, and it might not work well in a new setting. So always get that checked. And yeah, and if you want to break through the limit, look into the generalization. And that's pretty much it. Yeah, thank you for coming and attentions, and let's discuss what's your thought on this. So do I read the chat or do I do people just come in and talk? How does this work? And I hope facilitator, you here?
Yes, thank you, Bong, for your very insightful presentation, and also thank you to the audience that joined this session. So, if you have any question, feel free to chat in the write in the chat or turn on your mics and ask to our presenter directly. Thank you.
And so Morina has the questions that about the regularizations like dropout and so on. I think yeah, like data augmentations, dropout, it can help. But still, like we only test it on one data set. Like, when we change it, it can still flop. Like um, that things have been. I think it was just to reduce overfitting on one data set, but it does not guarantee the generalizations of that. Um, okay, another question is, does AI generalizations can lead to danger as it might not use as intended? I think that's the problem with innovations in general. Like anything can be used in any other way. Like a knife used for cutting meat can use to kill someone. So I think yeah, but we also need to keep in mind the ethics when deploying this type of products. Um, mhm. But yeah, of course, there are always ways to use it in a bad manner. Bad manner. That's very wrong grammar. Dun, dun, dun.
Yes, so while we waiting for the question from the audience, I have one question. So in our audience, might have like our junior, freshman or sophomore as well. So like if they want to go into the field of artificial intelligence or AI, yes, AI in short. So may you give some tips for them or some like advice in you involved in that field. So where should they start or like where should they explore first before they like try to build or go into the field of AI?
Sure.
Yes.
Let me try to share my screen in a different form. Wait, I cannot share my screen. May have screen record permissions. Blah blah blah. Okay. Can I share my screen? Okay, now. Okay, seems like this. Okay. Anyway, the screen sharing didn't work. Um, so I would say that I have one course that is quite useful. Mm, can you see my screen in any way?
For me, I cannot see your screen yet.
Okay, never mind. So I would say that I had one course which was very helpful. It was on Coursera. It was deep learning specializations. Like it holds a bunch of things. It has the basic, the images, the language. I think if you want to go into this field, start from there. Start from that basic, and always try to apply. Like some people might be so excited that they go to learning spree and then they practice, and after the learning spree, you just forget. So yeah, do learn, do try, and there's another thing on Kaggle, um, Kaggle.com. Over there has lots of data set that you can experiment and play around with. That's also a good place to try it out as well. Yeah. So short two courses, Coursera, and try it out on Kaggle or other data set you can find.
Yes, thank you. So I hope this help to our junior who want to explore in AI field.
Sure.
And so from your personal experience, from while you are studying or working, like do you like face any challenge in this field? Can like you explain what if you have any challenge, what are they, and can you share to us?
I think one of the biggest challenge in this field is that having the right parameter, like how many layers should you have, how many hidden state, how large is it, what is the embedding size, how many times should you train it. I think it's quite GPU intensive as you have to run it a lot of times, and sometimes you don't even know if it will works or not. When you click run, you just pray or go watch movies, and then come back and then try to analyze which one it fails and the score and so on. But yeah, I think it's really time consuming and it's really difficult in a sense that we don't know what's going on and we don't really know how should we really improve it in order to fix the problem it's having. But yeah, I think that's the most difficult stuff.
Oh, thank you so yes.
The next question is, am I studying or working in Japan? I studied in Japan and currently I'm working in Japan. I will be back soon for my country.
Yeah, so okay.
Um, it's in my early slide. It was Rakuten, and I work as application engineer.
What do you do as application engineer in Rakuten? Is it like you write algorithms or you do some research? What is your functions?
Okay, it's more like software engineer, more like building systems and API and stuff like that.
Okay. And do you plan to do a PhD?
That's also on my plan, but I'm more interested in using what I know right now to apply into some sort of products or startup. And yeah, and then later on I might resume, but applying those things that I learned is the priority right now. Does that answer your question?
Yeah. Thank you. There is another question.
And the question is, can I tell you guys my experience in Japan, how I got there? Okay, this may be not relevant to the topic, but real quick would be there's a MEC scholarship. It opens at that time around April. I applied, and I got in, and that's why I got here. And then I studied master, and then in Japan they're very open. You can stay to work, you can stay forever, up to you. But yeah. And in my team, do I use English or Japanese? It's mixed. The company itself, they want people to use English, but of course, Japanese is still used, but the official is like English, but still Japanese majority of the time. What kind of tech stacks, tool, frameworks, language you use at work? I think this type of thing is more like, is it confidential? I should not answer it, yeah. But I could say that during my master, I'm more using Python, PyTorch, scikit-learn, but most of the time PyTorch. But if you can have more specific questions, like what will you use it for, maybe I can provide a more insightful comment. I wonder if all of these questions are chatbot. I'm just talking alone.
Okay, thank you, Bong. So another question, if like, can you tell us what is your research in your master program?
The research at that time was about evaluating chatbot. so so for example, we have a chatbot and it just output answers. Like if you remember earlier, we just have input and output, and sometimes we don't know if the output is good or not. And sometimes it's hard to determine if it's a good output. Let's say, hi, and it's answer, how are you? How do you quantitatively determine that? So it's difficult. So that's my research is to determine the quality of the bot's response. And another work that I did following up that is try to create a dialogue model to generate a good response based on the feedback of the metrics. Hope that makes sense.
Yes. So which language that you apply in your research? Is it Khmer or English or Japanese?
At that time, I was it was English in short. It was English. The reason that it was English is that we want to push the field forward, and if we want to apply it in Khmer, it's very simple because as I explained earlier, we just change the input and the output, and we can use it in other languages as well. But at the time, I was hoping to push the front line of the languages, and that's why my focus was English because most NLP people primarily focus on that. Yeah, in the space. And do I have any suggestions for students who want to apply for the scholarship? Ah, have a good research topic. A topic that is beneficial for your country would help tremendously. At that time, my research topic, which I changed, uh, my research topic for the max applications was sentimental analysis. Is for example that people write comments on Facebook and you have a lot of comments, like 1,000 comments, and you don't want to read through all of them, so we can just use sentimental analysis to read the languages and then easily determines by average what is the sentiment or what is the emotions towards that post. And so, and I tried to tell some other use cases that it can be used and so on. And why do I choose that research topic? Bum, 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 bum. First of all, doing the model, it's quite complicated. And second of all, the evaluations metrics in dialogue is still limited. So for example, like this, in deep learning, it's really important to determine how good is the model. In dialogue, to determine that you have to use human to look at the reply. Oh, this is good, this is bad, this is good, this is bad, and then you can determine, oh, this is a good model. But if you experiment with 20 models, you have to do that 20 times, and you have to do 100 or 200 sample per model, and that is challenging. Even though we want to push this field forward, it's blocked by this evaluations. And that's why I focus on this first, so that if we have a proper evaluation system, then we can just try to push this using that. I hope that makes sense as well. What do you think AI in the next 10 years? So I'm gonna go through my slide. I think like as I mentioned, the most important to push right now is the generalizations of the common sense. Like, oh, fire is bad, don't touch fire, don't run into fire, or alert if there's fire, or don't hit a kid on the street, or a kid on the street may be in danger or something. So I think people right now are pushing towards that, pushing towards making the AI having some sort of common sense of, because to us it's obvious, everything it's obvious, the fan make it cold and so on, but it's not to AI. So I think people are pushing that, and if people can solve that, I think the practical applications can be enormous. Like first of all, the one of all, like self-driving car would be completely solved. You would see self-driving all over the place, autonomous robotics all over the place, if we can solve that. Do AI need network or system experience, or only programmer for building AI? I think some people, when they say AI, they prefer to the intelligence, whether the machine can mimic the human intelligence in a certain way or not. Like, can the AI make music? Can the AI draw some stuff, for example? In such sense, network and system experience may not contribute so much to it. I think programmer or modeling are more important in this case. Yeah. Okay. By the way, do we have 2 more minutes, or I have like 15 more minutes? Like, how many time do I have?
We have another 2 minutes
Okay.
for Q&A. Yes.
Okay.
So,
Sure.
Yes, we
Can
have
AI
another question.
draw something? So does a printer use AI? Um, it can generate some stuff. So for example, there's this. Oh, okay. There's this thing called style gun. It's so sad I cannot share my screen. But anyway, there's this style gun that they try to generates a new human face. Like for example, there is this A and then there's B, and then they can try to interpolate. They try to generate images to convert from A to B, like smooth transitions, not just transparency fading. No, it's like smooth transitions from A to B, and that's sort of that kind of case. Yeah, so it sort of can generate something to resemble something. Um, yeah, but does printer use AI? Maybe not. It's just ink and other stuff. Does AI really need mathematics? Do you recommend us about math? Should we learn to apply for AI? I think if you want to be really good at it, math is important. Like, but not too heavy math. Like some sort of derivative is enough. You don't need integral. Just a little bit of derivative. Um, when we use it, we don't need AI, but we use. Oh, sorry. When we use it, we don't need math, but we need math to understand why it may not be working. For example, some math functions may make the AI didn't work well. So, for example, I'm not sure if you're familiar with this, but to everyone as well, if you use sigmoid as the activations functions, the weight will be divided by 4, and so the back propagations is not as good as tangent or something. So and to know this, sometimes you have to look at the formula and so on and so forth, because AI by default built entirely on math. But when we use it, we don't need math anymore. But we need math to maybe understand, oh, maybe this is the problem. And you need math when you want to create new model. So for example, if you just take the model that researchers built already, maybe you don't need math. You just use it and apply, because it's all about input and output. But if you want to build the center, if you want to create a new model, then yes, I think having a good math, a little bit of math background in your pocket should be beneficial. Phase transitions, I think it's maybe phase gun, gun as in GAN, phase gun or style gun. I think looking at that sort of key term could lead you to that phase generation thing. Let me look at the exact name. Oh no, it's out of time. Yeah, but
Okay.
let's see me phase gun. Let me know when you're back to homeland. We can visit you to ICT students. Oh, yeah, sure, no problem. It would be perfect.
Yes, so thank you so much for your sharing session. So I think we wrap up the session here, and I would like to thank to you and all the audience that joined the session. So we have another session at start now. They already start. So
Sorry.
yes, so please go to visit our project presentation from the seniors as well. And yes, so see you at the senior presentation. Bye bye, everyone.
Thanks, everyone.
Yes, thank you.
Testing 2.